Hi everyone, and thanks for joining us for another particular live webinar. This is Britt King. Today, Mauro Servienti will show how to master the NServiceBus Configuration API to gain full control over endpoint runtime behavior. Mauro is a particular software solution architect and a Microsoft MVP for Visual C#.
Hello everybody, and welcome to this particular webinar about the Configuration API. And as Britt said, my name is Mauro Servienti. I'm a particular software solution architect and a Visual C# MVP, and also an NServiceBus champ. You can find me online on the NServiceBus Google group and as a support engineer in the guidance and support team at particular. And let me start at first with the good news. We have just released NServiceBus V5 that is alive and kicking on Nugget and can be downloaded since last week. And we have a brand new configuration API that is solid and totally redesigned from scratch to accomplish the requirements and the complaints that we have received all over these years. And we are ready to start. Just a small side note, the V3 and V4 configuration API, what we are all used to, is basically the main reason why I'm here now. And it happened that 2.5 years ago, I was working on a huge project with lots of endpoints and for a big customer, and we were at that time in the early stages of V3. And I remember that I sent out a not so politically correct email to Andreas and Udi complaining about the complexity of the configuration API. And the aim of this webinar is to show you how the V3 and V4 configuration API works, and then introduce the new V5 configuration API with all its new features and all its new settings and all its new behavior to configure your endpoints and your daily job with an NServiceBus. But before, why do we need a configuration API at first? Why do we, as developers, need to interact with the configuration API during our daily usage of endpoints, of NServiceBus endpoints? The main reason is that NServiceBus exposes a lot of features that we need to be able to basically take control over, and the basic list of these features is the following. And NServiceBus is capable to host our endpoints, and we have multiple hosting strategies. A self-hosting strategy where we can host by our own NServiceBus endpoints in our own applications, such as a WPF application or a console one, or we can leverage the power of the NServiceBus host. And in both cases, we need to be able to configure the NServiceBus behavior. The transport, we need to be able to tell NServiceBus which transport to use and configure transport options. Most of the transport options should be configured via code, and some of them, such as for example, the connection string, can be configured via an application configuration file. We need to be able to explain to the endpoint which serialization type we want to use and its option 2. And given the fact that in V3, has been introduced the unobtrusive mode that allows us to get rid of the message interfaces that we are used to decorate our messages with, we need to find a way to explain to NServiceBus how to distinguish between commands and events. Also, NServiceBus heavily relies on dependency injection and inversion of control container, and we need to be able to interact with the built-in container or entirely replace the container using our own container. Basically, the main reason can be that we are already using an inversion of control container, and our application is based on inversion of control, and we want to mix up things in order to be able to allow NServiceBus to resolve via the same inversion of control container our types, and we want to be able to resolve NServiceBus types using our own container. The other thing that NServiceBus needs is a persistent storage in order, for example, to persist subscription or timeouts, stuff like that. And we need to be able to configure which persistent storage should be used, and the specific configuration need of the chosen persistent storage. We all know that by default, NServiceBus comes with RavenDB bounded. That's true until V4. In V5, RavenDB has been externalized. It's not anymore in the core of NServiceBus. There's a specific NuGet package to add RavenDB as a persistent storage, and we'll see how to do that during this webinar. And then we have features. Features are a high-level concept that allows us to group a set of settings and expose a configuration API or deal with the configuration of that specific settings using the single feature. It's like saying, I want to enable sagas. And enabling sagas means that we are going to change a bunch of settings, and we are just doing that, enabling or disabling an entire feature. In NServiceBus V3 and V4, basically the configuration API works in the same way. The first thing, as we have seen, that we want to be able to take control over is the hosting process of our endpoints. And from the configuration point of view, all we need to do is to define in our project a class that by default is called endpoint config. But the important thing is that it implements the I-configure this endpoint interface. Once we have defined this class, and once we have added to our project the nservicebus.host NuGet package, this class will become the entry point of our endpoint and will be the one that will be scanned by NServiceBus and served. NServiceBus will look for this class and will use this class as the main entry point of our application. So from the NServiceBus host point of view, the class that implements the I-configure this endpoint is the class that will be considered the entry point. The name of the class itself is not important at all. By default, the NuGet package will run a PowerShell script that will create a class called endpoint config, but its name is not important in the end. The as a server interface or as a publisher interface, as a client interface defines the role of the endpoint. By default, the role of the endpoint is as a server. That means that the endpoint can receive messages and send messages. And specifically, what a server endpoint in V4 can't do is to publish events. In order to let the endpoint be a publisher, we need to define the endpoint as a publisher. That simply tells to NServiceBus that these endpoints will be capable to publish events to the outside world. The other available role is as a client. That basically means that the endpoint will be a send-only endpoint that cannot receive any message and will only deliver message to the outside and cannot publish any message. In all the samples that will be available for downloads, what I do is I customize the persistent storage in order to be able to run the sample without requiring any RavenDB server available. This is just required only to allow you to run the sample without installing and run RavenDB. And I'm just replacing the default RavenDB server using an embeddable document store that is an embedded version of RavenDB, and I'm using the configure.instance.raven persistence with store, passing in the new instance of the RavenDB document store. As we said, in V5, we removed the dependency of RavenDB, and we'll see how to use the new RavenDB dependency in a minute. The last thing we are doing at initialization time is the unobtrusive configuration. As we have said, we have removed the requirement to decorate our messages with the iCommand and iEvent interface, and we can explain to NServiceBus how to define commands and events, basically using a lambda expression, or a delegate in this case, that says every single type that which namespace end with the .commands namespace or end with the .events namespace should be considered a command or an event. In this case, the main advantage of this behavior is that we are not required to decorate our messages with NServiceBus interfaces. That means that we do not introduce a dependency on NServiceBus on our message classes, and we can have POCO commands and POCO events. If we decide to go down to the self-hosting route, in this case the sample is from a console application, we do not have an entry point defined by NServiceBus because the console application itself will be our entry point, can be a Windows service or the static void main method of a WPF application, for example. This is the exact same code to replicate the behavior we've seen with the NServiceBus host in the previous slide. Basically, we are setting up the embeddable document store, defining that directory, initializing it, and then we need to take control over the entire configuration by our own. So we are calling the configure.with method that basically under the hood what does is scan all the assemblies within our bin directory, looking for types interesting for NServiceBus. We are configuring NServiceBus telling NServiceBus to use the default builder, that will be the internal default inversion of control container that currently is out of whack. And then we are telling NServiceBus to use Log4net as a logging framework. And as before, we are defining the unobtrusive configuration in the same way, adding the RevenDB persistence using the embedded document store created before, and then we need to do a bunch of other steps in order to have it up and running. And it is to define that the bus will be a unicast bus, that is currently the only available bus type. We need to load message handlers that what does is basically scan all our types, looking for types that will be considered message handlers, and then we need to finally create and start the bus in order to have a bus up and running. It is much more verbose than what we should do with the NServiceBus host. And basically, if you think about it, we are doing things that we are basically not really interested in. So why do we need to define that the bus will be a unicast bus, or we need to create the bus and then start it and stuff like that? Can't we get rid of that? So the first question should be at this time, why do we need to use the NServiceBus host? Well, at first, how? It's just a NuGet package. As soon as we create a class library project and add the NServiceBus.host NuGet package to that library project, what happens under the hood is that a PowerShell script will create the endpoint config class for us, and then we'll define how the project will be run when we press F5 on Visual Studio. Running a class library project is not supported by Visual Studio out of the box, but what happens under the hood is that the PowerShell script will replace the startup program, telling Visual Studio to start up the NServiceBus.host.exe that will host our own code. But the real question should be, why do we need to go to the NServiceBus host? Basically because we are going to handle all the details for you. The NServiceBus host can be run as a console application while we are developing or debugging our own application, and can be installed as a Windows service in production without requiring any change. It's just enough to run the NServiceBus host.exe with the /install command line argument, and our code will be hosted within a Windows service installed on the production machine. So it's much, if we do not really need to have full control over the configuration process, or when the configuration and the bus are created, the easiest way to host NServiceBus endpoints is via the NServiceBus.host. Can we customize the configuration? Yes, obviously. Whenever we need to deal with self-hosting, we must have control over all the details. As we have seen, we need to take care of everything when we self-host the bus on our own. But when using the NServiceBus host, we just need to define the endpoint config class that implements the I configure these endpoints interface, and that's it. In order to have control over the configuration and customize part of it, we have basically two different approaches. We can have two different approaches. We can implement on the endpoint config class the I want custom initialization interface that requires us to define a void init method, and the complex things from a certain point of view is that the I want custom initialization interface should be implemented on the endpoint class. At that stage, there is no dependency injection available yet, because we haven't configured anything yet. And in order to start the configuration process, we need to call configure.with as if we were in the self-hosting scenario. But we do not need to create the entire configuration by our own, because the NServiceBus host will take care of the missing details for us. If we need to participate in the configuration of an endpoint, we can, on a different class, as the one explained here, shown here, the custom initialization class, implement the I need initialization interface. That's basically as the same init method, and it cannot be implemented on the endpoint config class, because the endpoint config class won't be considered as something that can implement the I need initialization. Will be called after the configure.with that will be done by the NServiceBus host or by our I want custom initialization implementation, and will be called after the container has been set. So basically we can rely on dependency injection in this class in order to move on and do something interesting with our own types. And what we can do is, for example, in this case, we are calling the configure.instance, that is the current configuration, and we are telling to the configuration to use the in-memory timeout persister. The in-memory version, there is an in-memory version of all the persister that is really useful at demo time or at development time in order to allow us to be up and running with an endpoint within Visual Studio without taking care of all the persistent details. And we can take care of them right after we have set up our environment. Sorry. But if we need to extend the behavior of an endpoint, what options do we have in V3 and V4? Basically, we have basically two options in V3 and V4. And the first option, and that is really low level, are called message mutators. And in this sample, we have what we are used to, that is the I configure this endpoint class. We have a custom initialization class that implements the I need initialization. And what we are adding here is that we are going to the configurer instance. The configurer is the right part of the dependency inversion of control container. So basically, we can use the configurer instance to configure components registered in the dependency inversion of control container. And in this case, we are registering a new class that is the my multipurpose mutator that we'll see in a second. And we are telling the container that this class will be registered as a single instance, basically meaning that each time we try to access this class, the same instance will be returned. The first time will be created, and then the container will cache the created instance and will reuse that each time. The important thing with mutators is that we need to manually register mutators in the configurer in order to allow to tell NServiceBus that we want to plug in a new mutator. That is something that we do not need to do with the initialization implementation. Nowhere in our code we need to go to the configurer and tell NServiceBus that we need to have some custom initialization. So we do not need to tell anyone that we have a class that implements the initialization interface. In this case, at startup time, the NServiceBus host, or the configuration of NServiceBus, will scan all the available types, looking for types that implement the initialization interface. And all these types will be loaded and can participate in the configuration process. In the case of message mutators, they need to be manually registered and configured. What is in the end a message mutator? A message mutator is just a simple class that can implement one or more mutators interfaces. There are 4 different mutator interfaces. The iMutate outgoing transport messages, iMutate incoming transport messages, deals with transport messages, so low-level messages at the transport level that are outgoing or incoming, depending on the interface we choose to implement. And then we have the iMutate incoming messages and iMutate outgoing messages that will be at a much higher level than the transport message, and we have the deserialized message available, and we can do whatever we want with the deserialized message. As before, the 2 interfaces allows us to plug the mutator at the incoming message level or at the outgoing message level. We can implement all the interfaces in a single class, and once it is registered, NServiceBus will take care of invoking the correct method at the correct time. The main difference between the 2 implementation, transport message level or message level, is that at the message level we just have the single message that is going to be delivered. At the transport message level, we have the logical messages, and we have the transport message that is the serialized version with all the headers and all the configuration ready to be delivered on the transport. So we are at the lower, in this case, the message mutator is at the lower level possible from an extensibility point of view in the NServiceBus pipeline. In NServiceBus V3 and 4, we have another extension point that is called unit of work. As before, a unit of work must be manually registered and configured, and in this case we are using a different dependency life cycle for the unit of work, and we'll see in a minute the meaning of this life cycle. And the my unit of work class is nothing else than a class that implements the iManage units of work interface that requires us to implement and to expose a public void begin method with no parameters and a public void end method that can take an exception. The begin method will be called at the beginning of the message handling process, and the end method will be called at the end of the message handling process when the message handling is completed. And if during the handling message process an handling exception has been raised, we can access the exception in the EX parameter passed into the method. So we can know if the events and the message handling has failed and why. The important thing that is true both for the manage unit of work, the iManage unit of work implementation, and all the message mutators implementation is that given the fact that they are registered into the internal or user-provided inversion of a control container, they can rely on DI to work. So basically, if we need to have an instance of the bus in this class, we can simply add a public ibus mybus property with get and with a public getter and a public setter, and with the built-in or the user-provided dependency inversion of control container will take care of filling that property with the current instance of the bus. The dependency lifecycle is really important, especially for unit of works. We have 3 different life cycles supported in NServiceBus, and we are abstracting on top of what the inversion of control containers supply, and we have 3 main life cycles. The single instance one, that basically is a singleton. The class is created the first time, and then the instance is recycled, and the same instance will be returned each time. So be really careful in storing some state in that instance, because that state will be shared across all the callers. An instance per call, dependency lifecycle behavior, that basically means that the class will be a transient instance, meaning that each time we ask the dependency, we ask the dependency inversion of control container to resolve an instance of the type for us, a new instance will be created. Thus, in this case, it's safe to have some state in these instances. And then the last one, that is the more complex, but it's also the more important from the NServiceBus point of view, is the instance per unit of work, or in inversion of control container terminology, it's scoped to the message lifecycle. Basically meaning that a new instance will be created for each received message, and for all the lifetime of the message in that endpoint, the same instance will be returned at the same message context. Given the fact that NServiceBus handles messages in a multi-threading manner, if we configure our endpoint to use, for example, 5 threads, that means that we can handle 5 messages at a time. And this means that in this sample, 5 my unit of work instances will be created, and their life cycle will be scoped to the same life cycle of the message. Then a new message coming into the endpoint will have a new my unit of work. In this case, it's safe, and we can say that we can store inside the my unit of work instance some state that is related to the message itself. And we can store that state into that instance, because that instance will be alive for the same time as the message. Which are the pain points of the V3 and V4 configuration API? Well, the order in which the Fluent API methods are called is really important. We cannot do whatever we want. Despite it is a Fluent API, methods must be called in a specific way. Not every single method, but for example, if you need to define the endpoint name, the defined endpoint name method should be created before anything else. The second one that should be created will be is the inversion of control configuration definition. So if we want to plug in our inversion of control, we should do that as fast as we can. And if we want to simply tell NServiceBus to use your own built-in, we should call the default builder method on the Fluent API as soon as we can. the fact that the I want custom initialization interface cannot be defined on the endpoint conf list class. Sorry, the I need initialization, that slide is wrong. I'll take care of correcting it as soon as we finish. The fact that the I need custom initialization cannot be defined on the endpoint config class is somewhat misleading because we do not expect this behavior. There are too many ways to achieve the same goal with small and subtle differences, and sometimes it's hard to understand which is the best choice. The fact that the configure.instance is not always available, it depends on where we are in the configuration step, and sometimes everything blows up because we are trying to access the configure.instance too early, and sometimes we need to revert back to configure.with in order to start the configuration from scratch. And there is a lot of inconsistency in the extension methods naming. So we have extension methods for the RavenDB persisters configuration, and the naming of all these methods is not consistent with the other persistence extension methods and stuff like that. It's not that easy to, at the first time, to start dealing with the configuration API. The other side note is that we basically obsolete most of the configuration API in V5, and we are happy now to introduce the new configuration API. And just repeat after me. We have no more statics. No more. There is no more static methods or no more static properties in order to start up a new configuration and to deal with the configuration at all. Starting once again from the beginning and taking a look at how the NServiceBus host works in V5, we have a simpler configuration system. We will be provided by the endpoint itself with an instance of the current configuration. So we do not need to access some static instance property in order to access the configuration. And we can customize the configuration according to our needs, as in this sample. The new I configured this endpoint interface will require us to define a customize method that accepts a bus configuration instance. And notice that the bus configuration instance is not a runtime configuration, but is just a startup configuration. It is something that will be used to create the bus, and then the bus will have its own runtime and read-only settings that will be available to read. That can be read by the user, by our code, but cannot be changed anymore. So the bus configuration is just a startup configuration. And in this sample, we are going to ask to the endpoint to use as a persistence the in-memory persistence. And we will use generics to define quite anything on the new configuration, explaining to the configuration that what transport we want to use, which persistence type we want to use, all in this manner. And then we can access, as before, the unobtrusive conventions. In this case, it's not configuration anymore. And we are calling the conventions method, and then defining commands and events as before. So it's a delegate that will be called for each type found in the scanned assemblies. And from the self-hosting point of view, the configuration steps are simpler than ever. The first time I touched it, I have to admit that I've been really amazed by what the engineering team has done. And it's our responsibility to create an instance of the configuration. And it's our responsibility to only add what we really need. In the V3 and V4 sample that we had before, there's a huge difference between the number of lines of code required to self-host the bus compared to what was required to configure and customize the NServiceBus host. In this case, we have basically exactly the same number of lines. So we are creating a new bus configuration. We are configuring persistence as before. We are configuring attributive convention as before. And the only last thing we are required to do is to create the bus from the configuration and start it. If we are hosted by the NServiceBus host, the bus creation and the bus configuration creation is handled by the NServiceBus host itself. Since we are self-hosting, in this case, we are responsible to do both things. But we do not need anymore to call load handlers to define that the bus will be a unicast bus. It's everything to define which container to use. Since we are not telling anything to NServiceBus, NServiceBus will use the built-in container in this case. Can we customize the new V5 configuration? Yes, but we do not have to do anything special to customize the configuration, since the configuration is totally controlled by our code. In a self-hosting scenario, we are creating the configuration and we can do whatever we want. The I-need initialization interface is still supported. It has a different signature because now the init method will receive a bus configuration instance that is the current startup configuration. And we just need to plug in an I-need initialization only if basically whenever we need to customize the configuration from an assembly that has no control over the startup process. We are deploying some sort of a plugin, for example, to an endpoint, and that plugin will require to customize the configuration. In that plugin, there can be a class implementing the I-need initialization interface, and that class will be invoked, will be created, an instance will be created by the inversion of control container, and the init method will be called by the setup process in order to allow the plugin to do its own configuration. Everything has been redesigned from scratch in V5. It's much more solid now, and no need to call methods in the correct order. There is basically the Fluent API is much smaller, and we do everything starting from the bus configuration instance. We have a much more consistency in the namings of methods that do the same thing, and at each level we have methods that accept generic types, such as the one that we just shown, the use persistent using generics, and the same method as an overload that accept a system.type instance. It's really comfortable to have both possibilities, because sometimes we need to be able to define which persistence should be used. Basically, for example, defining it in a configuration file, where we can just add and up settings, defining the full type name of the persistence engine, and then calling the use persistent, passing in the system.type represented by that string that represents the full type name. As we said, RavenDB is not anymore internalized as dependency, but now there's a NServiceBus.RavenDB package that can be installed in the endpoint, and that will add in the IntelliSense a new type that is the NServiceBus.persistence.RavenDB persistence that can be used at the use persistence level in order to specify that we want to plug RavenDB as the persistence engine. In this case, it will be much easier to follow up with the evolution of RavenDB, and in order to being able to plug in new versions of RavenDB and do not have a strong dependency on the RavenDB, on the internalized RavenDB version. And from the extensibility point of view, The extensibility model has been totally redesigned, and a new pipeline has been introduced. So we now have a message handling pipeline that we can control or extend depending on our needs. And basically, we have full control over the entire incoming message flow. We have full control over the entire outgoing message flow. For example, in NSBCon in London and in New York, Indu and John demoed a way to change at runtime the serialization engine that will be used based on the message flowing in, something that in V4 was basically impossible. The new pipeline is based on pipeline steps that use a Matryoshka model where each step is responsible to invoke the next one. And the last one is supposed to be the message handler invocation step that will invoke our business code that will do something amazing with the incoming message. And we can plug our own logic at each level, or we can replace some of the built-in pipeline steps. What is a pipeline step? Basically, we call this step behaviors. And a behavior is just a class that implements the iBehavior interface, where the iBehavior interface is a generic interface, and that generic interface requires us to define if the behavior will be an incoming behavior that will be responsible to handle the incoming message flow, or to participate, sorry, in the incoming message flow, or will be an outgoing behavior. If the generic type, the iBehavior, generic type will be the outgoing context, the behavior will be introduced into the outgoing pipeline. In order to implement the iBehavior interface, we are required to define an invoke method, where the invoke method will receive the current context based on the direction, incoming or outgoing, and an action that allows us to call the next behavior in the chain, so the next pipeline step. The really interesting thing of this approach is that as in this sample, we can do something before allowing the next step to do something else. And we can do also something after the message has been handled, because the pipeline is a synchronous stuff where a message arriving at an endpoint will trigger a new pipeline, and that pipeline will be invoked synchronously, each step after the other. And as soon as we call next, we are blocked waiting for the pipeline to finish. So as soon as next return, that means that all the rest of the pipeline has been executed, and we can do something after the message has been handled. Or if it is an outgoing behavior, we can do something after the message has been delivered on the transport. How to tell NServiceBus that we want to add this class into the pipeline? We have basically two ways to do that. We can use the register method on the pipeline class instance, sorry, in the pipeline property on the configuration instance, calling register and passing in 3 arguments, where the first argument will be the ID of the behavior that must be unique at the pipeline level. The type of the behavior will be registered in dependency inversion of control container, so we can rely on dependency injection on the behavior itself, and an optional behavior description. So we can have we can add something that is human readable in order to understand what the behavior does. In that case, the behavior will be added at the end of the pipeline. If we need to take control over the position where the behavior should be added, we can use a register step. A register step is basically a class that inherits from the built-in register step class that is abstract. And what we should do is just define a public constructor with no parameters. The public constructor should call the base constructor, passing in the same free arguments as the register step before, the register method before. So the ID of the behavior, the type of the behavior, and an optional description, and then can call one of the methods available at the register step class that allows us to take control over the position in the pipeline. We can call insert after, passing in a well-known step ID, in this case telling to the system that we want to put our behavior right after the deserialized message behavior. We can replace a behavior, or we can try to insert a behavior after or before another one, only if that one exists. If you think about it, it's really interesting to be able to ask to the pipeline engine, has been registered this behavior? If yes, add my new behavior right after him or right before him, in order to not register anything that is useless at that moment. As soon as we do this, for each incoming message or outgoing message, our behavior will be instantiated via the inversion of control container and will be invoked depending on the direction of the behavior. Features have been upgraded to be a first-class citizens, and now we can. It was something that could have been done also in V3 and V4, but we are not so used to do that. We were much more used to build our own extension methods to the configuration API. Now, if we need to take control over a bunch of settings, or for example, register a couple of mutators that are still available, we can go. We do not need to convert our code to the message pipeline or to be a behavior. If there's a behavior in V5 that allows us to call message mutators as before. So we can go on using message mutator without any issue. We do not need to upgrade our code. If we need to define a feature, we can create a class that inherits from the feature-based class and override the setup method. A feature will be called after the configuration is completed, and features can be enabled or disabled at the configuration time. So we can call enable feature using the generics version or the overload that takes the system.type as an argument. And the configuration itself, as soon as we finish the configuration, will call for each enabled feature the setup method, where we have available the container, the pipeline, and all the read-only settings at the configuration level, and we can decide what to do in our feature in order to move on and configure a bunch of stuff. From the persistent point of view, we now have a lot of different persistent implementation for different storages. So we can take control over each single storage type and configure it according to our needs. In the endpoint config class, what we can do is, for example, in this sample, I've added the NServiceBus.RavenDB nugget package. So now you can write something like configuration.usePersistence, RavenDB persistence. And this will give me back a persistent settings instance that is related to RavenDB, and we can call the do not set up database permissions in order to ask NServiceBus to do not try to add your user to my database. And then we can call the for method, passing in a list of enum values saying I want to use the above persistent, the RavenDB ones, for sagas and for subscriptions. And then we are telling NServiceBus to use the in-memory persistence for timeouts. So we can take control over each specific settings. And for example, at the RevinDB persistence level, what we can say is use this document store instead of your own built-in one for sagas. Maybe because we have customized convention, or we want to take control over some specific setting that is not available at the NServiceBus configuration level. Can we take full control over the configuration? Both in V4 and V5, this can be done. So until now, we have seen that we can rely on the bus configuration class in V5 or the configure.with or .instance, depending on where we are, in V3 and V4. But in both cases, we can provide NServiceBus, we can supply NServiceBus an instance of two classes that can implement depending on the how much control we want to have. We can provide NServiceBus with a class that implements the I provide configuration of a specific config section. So for example, message unicast bus. I provide configuration of unicast bus means that we are telling NServiceBus we are responsible to define the message mappings for this endpoint, and please NServiceBus, do not go and read them from the application configuration file, because we have stored them in some database and we can load them for you. In this case, we can define as many classes as we want that implement the I provide configuration of some configuration section, or if we want to have full control over the configuration, we can provide NServiceBus an instance of a class that implements the I configuration source interface. In V4, this call must be the first right after with. So we can call configure.with.custom configuration source the instance of our custom configuration source. In V5, whenever we want, we can call custom configuration source passing in the same instance. And then NServiceBus will call us asking for each section and telling us, okay, now I need the unicast bus configuration section, or the encryption section, or the audit section, and so on. And we can choose where to load each settings from, depending on our configuration and our settings repository. Some resources that we have on docs.particular.net regarding the Fluent configuration API in V3 and V4 and the new configuration documentation in V5. We have basically two articles regarding the Fluent configuration API, an introduction to the Fluent configuration API, where I detail all the details related to how to host and take control over the configuration customization of your endpoints, of our endpoints, and then a detailed explanation of how each configuration API Fluent method works in V3, Fluent method work in V3 and in V4. And then we have an article regarding how to customize the configuration API, taking full control over the configuration. So the I provide section or the I custom configuration source stuff. V5 configuration documentation is still a work in progress. We are nearly ready to publish it, and we already have a message handling pipeline article detailing, introducing the pipeline and detailing which is the built-in pipeline, what each step in the pipeline does, and how to introduce your own step and plug it into the configuration API, into the NServiceBus endpoint lifecycle. And so thank you very much for attending this particular webinar, and I'll give back control to Britt in order to handle questions.
Yeah, just stay there, Mauro, if you would. Leave that slide just where it is. Yeah. We'll keep that up. Let's get to the questions. Early in your presentation, Thomas asked, First he asked, does NServiceBus 5 use .NET 4.5 or .NET 4.5.1?
It's something. That's a good question.
Well, the reason he was asking is because .NET 4.5.1 has transaction support fix for async, and he was wondering if version 5
I need
has
to
that.
I need to check it, and I think that is something that we need to add to our documentation. I'm not sure what the answer is at the moment, so I'll check it and take care of answering or to add it to our documentation in order to detail it.
Okay. So Thomas, we'll get back to you on that via email. I'll pass that your email to Mauro for him to contact you.
Yeah, thanks.
Okay, the next question, George asks, does code for unobtrusive config in define command as run every time when a new message arrives?
No, it runs only the first time at scanned, when all the types are scanned at startup times. Basically, what happens is that NServiceBus will scan all the available types in all the available assemblies. We can customize which assemblies are scanned by NServiceBus. By default, everything available in the bin directory will be scanned, and all the types are passed into the define commands or events, or there's also a third method called define messages as, that basically tells NServiceBus this class is a message, so can be sent. And at startup time, what happens is that the NServiceBus configuration will call for each type our implementation, asking if that type is a command or an event, and that information will be cached.
Marcus asks if it's possible to configure an endpoint to mix non-transactional and transactional messages on the same endpoint.
I think the answer is by default, via the configuration, no, because the transaction support is at the configuration level, and there is no way via the configuration to take a decision based on the incoming message. What can be done in V5 now is to replace the unit of work pipeline behavior, introducing our own, and we have full control over the life cycle of the unit of work and thus over the life cycle of the transaction. And we have the message in our hand, and we can decide whether or not to wrap the message handling within a transaction scope or not. So it's not really easy, but it's something that can be done.
Okay, David asks if NServiceBus 5 uses Log4net.
By default, there's an internal logging engine that is used if nothing else is configured, and as usual, we provide packages for different logging frameworks such as Log4net and so on. So if your project already have a built-in logging framework, you can plug your logging framework into NServiceBus in order to have all the logs in the same place. That is something that is basically really useful.
Jeffrey asks if you could explain again what you meant by required to plug in from an assembly that has no control over the startup process.
Oh, it's something that I'm working on right now. For example, I'll do a much easier example. That is, in NService, now the particular platform as Service Pulse and Service Insight. And Service Pulse, for example, relies on endpoints sending heartbeats. Heartbeats are just plain messages sent by an endpoint via the bus to the Service Pulse endpoint, well, to the service control endpoint, but that's not important at the moment. And what happens is that we do not want to require the user to do any special configuration in order to plug their endpoint into this behavior. So what the user needs to do is just add a reference to the service control.orbit plugin into his endpoint, and what happens at runtime is that in that DLL, in that assembly, there's a I need installation class, a class that implements the I need installation interface, and that class will be created and invoked by the NServiceBus configuration startup, and that class can participate in the configuration, basically without requiring anyone to do anything. What we generally use to call this class also some sort of a installers, because we can spread our configuration code across many assemblies, and each assemblies will be responsible to participate in the configuration and add its own requirements. And in this case, we do not need to have one single place where all the configuration must be defined. But each assembly, it's enough to add a reference to that assembly, and everything just works out of the box.
Scott asks if Service Pulse and Service Insight support custom routing topologies when using RabbitMQ transport.
It's a good question, and I currently do not have an answer, so I'll ask, and RabbitMQ topology with Service Pulse and Service Control and Service Insight, sorry. Okay.
Okay, Scott, so we'll get back to you with an answer on that. That was the last of the questions that I can see. Looks like we've made it. We're at the top of the hour. So thanks everybody again for attending. So just to let everyone know that we had a really good time at NSBCon New York last week. Enjoying sessions from Udi Dahan, Oren Ini, Ted Neward, and many more. We recorded all of the sessions, and we should have them ready for viewing next week. So check your inbox. Speaking of Udi, he's going to be racking up more frequent flyer miles this month and next, delivering his ADSD with SOA course in London at the end of this month, followed by sessions at the Build Stuff conference in Lithuania, then back to London for the Microservices conference in November. Also, look for NServiceBus champ Jimmy Bogart in London in December, where he'll be delivering Udi's NServiceBus course as well. Go to particular.net/courses and events for details. That's it for today. On behalf of Mauro, this is Britt King saying so long for now, and see you on the next Particular live webinar. Bye, everybody.